Hey guys, today I want to go ahead and talk about another type of FRQ that you guys are going to be able to see, and it's called rate accumulation. And let me kind of set the stage for you guys. Rate accumulation using the integral. Hopefully, you guys have heard it before and remember it, but remember when we were talking about the integral, the antiderivative. The integral is basically the area underneath the curve. Okay, and if you have this situation, for example, this example is real life situation. You have a vehicle, a car traveling, okay, at a constant rate of speed here. On the left hand side, you have the rate, okay, it's in miles per hour, and on the x-axis you have time, which is in hours. Well, the integral is the area underneath the curve. So if I go ahead and multiply that, notice here I have base is hours, and in the height, the y-axis is miles per hour. And what happens is the hours are going to simplify out. You're just left with miles. So when you integrate, you do the integral of of a function, area underneath the curve, you end up with the accumulation of whatever value you're talking about. In this case, you're accumulating miles. So that's what we're going to be doing. And you're going to be doing essentially the fundamental theorem of calculus. Okay, the integral from a to b of f of x dx is equal to capital F of b minus capital F of a. And you're going to be using that to rearrange and find different elements of the problem. So let's go ahead and see if we can do a few of these. You have water that's being pumped into an underground tank at a rate of 6 gallons per minute. Water leaks out of the tank at a rate of square root of t plus 4 gallons per minute for the time interval between 0 and 90 minutes. And it says at time t equals 0 at the start, the tank contains 50 gallons of water. Okay, now look at this carefully here, because it's really written here how it's going to tell you what to do. How many gallons of water leaked out of the tank? You see that? How many? That already tells me I'm probably going to do the integral. And look at here. Water is being pumped into the underground tank at a rate of 6 gallons per minute. So this is already a rate. So water is going into the tank. So picture that. Now water leaks out of the tank at a rate. You see that again? Rate of square root of t plus 4. Okay, gallons per minute for between 0 and 90 minutes. Okay, and it tells us that it starts off with 50 gallons. So, and when you start off with these problems, the first one's usually is going to be the easy one, letter A. Really short and to the point. It says how many gallons of water leak out of the tank during the first 5 minutes? Well, how many? That means you're looking for an amount, an accumulated amount over the first 5 minutes. So you're going to do the integral from 0 to 5 of the function that gives you water leaking out. Well, what's leaking out? This guy. This is the rate. So you're going to do square root of t plus 4 dt. And that's it. So now what do? I got to do the antiderivative. I got to solve it. So remember that is same thing as 0 to 5 of t plus 4 to the 1/2 power dt. Okay. And hopefully I'll just go ahead and do the u substitution. Let u equal t plus 4. That means du is equal to dt. That means this becomes the integral of u to the 1/2 dt becomes du. Let's go ahead and change this. So we go if u is 0, 0 plus 4 gives you 4, and then 5 plus 4, that's 9. Remember, you have to change the limits of integration if you're talking in terms of u. Okay. And so then we go on. Antiderivative becomes u to the 3/2. Divide by 3/2 is the same thing as multiplying by 2/3. And then we go from 4 to 9. And then we're going to go ahead and do that. So let's go ahead and do it over here on the left side. So we're going to get 2/3 times 9 to the 3/2 power minus 2/3 times 4 to the 3/2 power. All right, so what is 9 to the 3/2 power? Now be careful, remember 3/2 power, that's the same thing as writing 3 squared and then 3/2. What's going to happen here, the 2's are going to simplify out. You're going to end up with 3 to the 3rd power, which is going to be 27. Okay, and then what about here? You can write 2 to the 2nd power, and we're going to have also the 2's cancel out again, and you can have 2 to the 3rd power, which is 8. So this is going to give me 2/3, 3 to the 3rd is 27, minus, and then you have 2/3 times 2 to the 3rd is going to give me 8. So you can have 27 divided by 3 is 9, times 2 is 18. So this gives us 18. Minus, and this gives us 16/3. Okay, keep doing the math. 18 times 3, that gives me 54/3 minus 16/3. That's going to give me 38/3. Well, what are we talking about? Okay, we're talking about gallons. Okay, so in the first 5 minutes, you have accumulated 38 1/3 gallons that have leaked out. How many gallons of water leak out of the tank during the first 3 minutes? 38 1/3 gallons. And that's it. That's it. Part B, it says how many gallons, okay, of water are in the tank at t equals 5 minutes. So think about this. Think about what's going on, okay? Water's going in. You start off with 50, okay? Water's going in. All right, water's going in, but at the same time it's leaking out. So let's go ahead and set it up with the fundamental theorem, okay? Well, how do you set that up? Well, we're doing the integral from 0 to 5, okay? Because it says the first 5 minutes, right? Okay, now what's going on here? All right, now notice here, look at your rates. Water is being pumped into the underground tank at a rate of 6 gallons. It's going inside. Okay, cool. It's going in, so we're gonna go, it goes in, so it's positive 6. But look at this, and then we have another rate that does what? It's leaking out. So I'm gonna do this, minus the rate that it's leaking out, which is square root of t plus 4. Okay, you see how I did that? All right. Now, the other thing that we're talking about, okay, how much do we start off with? Okay, how much do we start off with? Well, we start off with 50 gallons. So right here, right in front, we're going to do 50 plus, okay? That's the original amount, 50 plus, and then the integral from 0 to 5 of 6 minus the rate that's going in minus the rate out, okay? And actually, I should have done this. I should have done 0 to 5 of this guy here. All right. To give you a better understanding, but then I went ahead and just did it this way. And I think if you have this as an understanding, it'll make sense. So this is our scenario. The stuff that we start with, okay, plus 6. 6 is positive. Why? It's a rate that's going in, okay, minus the rate that's going out. And you're always going to have that relationship, what's going in minus what's going out. So now, okay, I'm going to take out the 6. Okay, so I'm going to have 50, okay, plus, and actually, let's see here. We can do 2 integrals from 0 to 5 of 6 minus the integral from 0 to 5 of square root of t plus 4. And I just want to show you guys something. What's the antiderivative of 6? Well, it's 6t. Okay, because we're talking about in terms of t. So we can go ahead and write 50 plus 6t, okay, the integral from 0 to 5 minus, and then we do the antiderivative of this guy here. okay, which we already found in the first one, right? The integral from 0 to 5, didn't we already find this value here? Yes, we did. We found it. It wasn't it 38 thirds? It is 38 thirds. So all I have to do is really find this part here. So now I have 50 plus, okay, well, 6 times 5. Let me just do it in brackets. 6 times 5 minus 6 times 0. Okay, and then the minus 38 thirds. So 6 times 5 is 30. That's a 0. 50 plus 30, that gives us 80 minus 38 thirds. And then you do the math, that gives you 240 minus 38 over 3. And what is that going to give you? 202. 202 thirds of gallons. Okay. In the first 5 minutes. But notice how we did that. Okay. We start off with plus the integral. Okay, it's rate accumulation. Well, how do I know that the 6 goes on the inside? Well, you got to read it carefully because it says water is being pumped into an underground tank at a rate 6 gallons per minute. Water leaks out at a rate of this amount, of this rate. So that's how I know it goes inside. Okay, guys. So let's go ahead and see if we can do letter C. It says write an expression for A of T, the total number of gallons of water in the tank at any time T. Okay. So we want the total number of gallons. And I think I'm going to show you guys how to do it this way. We know we have to do the integral, okay, from 0 to any time T. Okay. All right. Now, it's always what goes in minus what goes out. So what's going in? What's the rate that's going in? 6. Well, what's going out? Minus. What's going out? Well, it's the water leaking out, which is the radical T plus 4. Okay. And that's what's happening. Okay. Now, if I do the fundamental theorem, okay, if I do the fundamental theorem, you're going to equal, I'm going to use A for amount, A of T minus A of 0. That's a fundamental theorem of calculus, okay, F of B minus F of A. So I'm going to rearrange this now because I want to figure out, it says write an expression for A of T. So this guy is going to stay. This guy, I'm going to bring him to the left and put him in the front. So let's write it nice and neat here. A of T is equal to A of 0 plus the integral from 0 to T, 6 minus radical T plus 4, and then that's dt. And that's my equation. And that's essentially what we did over here. What's A of 0? Well, that's what we start with, 50, plus the rate going in minus the rate going out. And it's all in under the integral. Why? Because the reason is because it's a rate. Okay? And that's basically it. That's part C. Okay? Because it doesn't tell me, it just says write an expression, don't solve it. So now we're going to go ahead and do another part. It says part D. Okay? And it says at what time T between the first 90 minutes is the amount of water in the tank a maximum. And the reason I like this question is because it forces us to go back and do our look at our derivatives. Okay, maximum. How do you find a maximum and a minimum? You got to find the derivative, set it equal to 0, your critical points. Okay, so for the max, how do we solve that? Derivative a prime of t, set it equal to 0. You find your critical points. And the third thing is you do your number line. Okay, remember that? So, what's our equation? We have our equation, our general equation for A of t, which is A of 0. Okay, well, A of 0, well, we know it's 50 plus the integral from 0 to t 6 minus radical t plus 4 dt. So now I got to take the derivative of this guy. Okay, so a prime of t, the derivative of 50 is 0 because it's a constant. What's the derivative of this guy? Remember, this is the second fundamental theorem. And the derivative of the integral is going to cancel it out. You're going to be left with this. Okay, and you're going to be left with 6 minus, and I should have used another variable and I didn't, I'm sorry. But remember, this guy replaces this variable inside here, and we'll just leave it the same, which is t plus 4, and that's it. Okay, remember the second fundamental theorem, the derivative of the integral cancels out, and then this guy replaces it. All right, they cancels out, and then you're just left with the inside. So now, what do I do? Set it equal to 0. So I have 0 is equal to 6 minus radical t plus 4. Now I have to solve this guy. Okay, so that means bring that guy, the radical, to the left. You have the square root of t plus 4 is equal to 6. Square both sides, you end up with t plus 4 is equal to 36. You solve it, t is equal to 32. So at 32, at t equals 32 minutes, you have a critical point. What do you do now? You find 32, that's my only critical point. Now you go to a prime of t, you're going to plug in a value. What's the value to the left of 32? 0. Okay, a prime is here. You plug in 0, you get 6 minus radical 4, which is 6 minus 2, which is a positive. It's going up. Good. What happens to a number to the right of 32? A big number. Guess whatever that is, and you're going to end up with a negative. So what happens? You see how you have a positive and a negative? So therefore, this is a max. Okay. All right. So there's a max at t equals 32. And then you can write because, okay, and you can say a prime of t is positive, okay, for t less than 32, and a prime of t is negative, that's how we say negative, for t greater than 32. And that's it. Now the first one's might be a little bit confusing, but let's see if we can do some more and do these together and figure them out. So I'll give you another example. I want to do as many of these as I can for you guys. All right. It says the rate at which people enter a theme park on a given day is modeled by the function. It says E for entrance. And I just kind of switch around these numbers to mimic an old AP question. So this is the entry point, and then the rate at which the people leave the same theme park on the same day is modeled by the function L. That's leaving, okay? All right. So it says both E of t and L of t are measured in people per hour. So notice that. What is this? People per hour, right? All right. What does that tell you? That's a rate. So this is a rate and this is a rate. And time t is measured in hours after midnight. Okay, these functions are valid between 10 and 23 hours during which the park is open. Okay, so if this is hours after midnight, this is 10 a.m. to 11 p.m. All right, so at time t equals 10 in the morning, there are no people in the park. All right, cool. So now it tells us how many people have entered. There it is again, how many people have entered the park by 4 p.m. Okay, so what do? I'm going to take the integral of what? What's the function that tells me when people are entering? Well, it's going to be this guy, E of t. Okay? The integral of this guy, E of t dt. Okay? And we're going from where to where? We're going from 0 to 16. Okay? And you know what? I didn't do the math ahead of this, but you guys can go ahead and do the answer, the integral, put it in your calculator. And I'm sorry, guys, that I wasn't able to, I forgot to do it early on. Okay, and then you just get your value. And that's it. That's all you do. I'm just going to go ahead and make up a value. I don't know if this is correct, but let's do 7,200. I don't know, something like that, just to kind of give you some reference. But that's it. That's all you do. All right, let's do part B. And don't forget, people entered by 4 p.m. Cool. All right. The price of admission is $20 until 4 p.m. After 4 p.m., the price of admission is $15. How many dollars? Okay. There's an amount again. How many dollars are collected for from admissions to the park on the given day? Okay, so think about it. People are going in and people are going out, right? But we're only talking about people going in. Now, there's two things here. The people going in before 4 o'clock and the people going in after 4 o'clock. So what are we talking about still only? We're only talking about the people going inside. So we're only talking about this guy. Okay. So basically, we have to multiply $15 times the number of people that are going inside. Okay, well, how do we get the number of people that are going inside? You do the antiderivative, okay, of the rate, E of t dt. From what? From 0 to 16. And now I'm going to add what? And actually, and I'm sorry, guys, this actually should be 20, right? Because this is before, this should be 20. Plus, and then after 4 o'clock, okay, it costs $15. $15. Okay. And then E of t dt. People are entering still. But what's are my limits of integration? It would go from 16 to 23. Okay. And then whatever value you got, and then you would use that. Okay. And that's it. That's it. And I don't know what value they got for that, but you just use your calculator and it would give you your value. And again, these values, I just kind of messed around with numbers and just to give you an idea. All right. All right, let's do the next part, part C. All right, it says let h of t be given, represent this function, this relationship here. The value of h of 16 to the nearest whole number is 3025. Okay. It says find the value of h prime of 16. All right. And explain the meaning of h of 16 and h prime of 16 in the context of the park. Okay. So now find the value of h prime of 16. So we know h of 16 is this amount. Okay. So h prime of 16, I have to take the what? The derivative of this guy. Okay, I have to take the derivative. So h prime of, now let's just do h prime of t first and then plug in our 16. What do? I got to take the derivative. What's the derivative of the integral? It cancels out. And what happens? You just plug in your t value. So when I take the derivative, you're going to end up with e of t minus L of t. Okay, no more dx, no dt. That's it. So now h prime of 16 is e of 16 minus L of 16. Okay, and what do you do there? And you actually, well, you would plug in 16 here, plug in 16 here, and I actually think I did that one. H prime of 16, I think I got something like 25 or something like that. Well, what does that mean? Okay, well, 25 what? Okay. Okay. There were 3,025 people, okay, in the park at t equals 16, okay, and the number of people okay, in the park actually increased, okay, increased at a rate of 25 people per hour at t equals 16. Okay, so that's what that means. So at t equals 16, at exactly this time, there are 25 people still coming into the park per hour. Okay, that's what that means. That's what that means. Okay, and what does h of 16 means? It tells us that's how many people were in the park, and at specifically at that point, then you have 25 people per hour coming in at that specific time. All right, guys. Let's do another one. Letter D. It says, at what time t between this time interval does the model predict that the number of people in the park is a maximum? Okay, is a maximum. Okay, well, wait a minute. What model? What model are you talking about? Remember with the one that they already gave us in part C. So you can see how these questions build upon each other. Okay, well, how do I find a maximum? You find what? Derivative, set it equal to 0, critical point, and number line, right? So derivative, we already got it. Here it is. We got to set this guy equal to 0. So h prime of t, we want to set it equal to 0. So that means e of t minus L of t, set that equal to 0. Okay. And, or the other way you can do it is take your calculator, e of t, and set it when e of t is equal to L of t. Okay, and find that time period, that time. And I don't know, let me see, I don't know if that was 21.12, something like that. But let's just say that's the number. I think it's off, but it's okay just for sake and purposes of how to do it. So we're going to have 21.12 here. That's your critical point. And then what do? You plug it into h prime of t. So you pick a value on the left, and actually let me do h prime of t is equal to e of t minus L of t. So to the left of 21, you would pick 0. You would plug it in here and see what value you get. Hopefully you get a positive. And then to the right of 21, you would get a negative, positive going up, negative going down. So this one would give you a max. Okay. All right, guys, let's go ahead and do one more. I try to do as many as I can. I'm sorry if I'm going a little too fast. I just want to do as many of these as I can. Okay. The next one, the traffic flow measured in cars per minute at a particular intersection, okay, is modeled by the function f, and this is it. All right. F of t is measured in cars per minute. So right away it tells me this guy is a rate, cars per minute, and t is measured in minutes. Okay. To the nearest whole number, how many cars, you see that again? How many cars pass through the intersection over the 60-minute period? The first part, letter A, is pretty simple. Okay. And I think this is a calculator problem. So we're going to integrate from 0 to 60 of what? F of t. F of t dt. And again, guys, I'm so sorry I didn't do the math for this one, but let's just whatever value you get, you would use there. And I don't know exactly. Let's just say it's I don't know, 85 or so, and then you would use the values, which is cars. Okay. And again, I'm certain it's not 85 cars, but I just didn't do the math behind it. But it's okay for the sake of time. All right. So part B, is the traffic flow increasing or decreasing at t equals 8? Okay. So at that specific time, is the flow increasing or decreasing? What does that mean? Well, that means the derivative at that specific point in time at t equals 8, is this flow rate increasing or decreasing? So what you want to do is you want to find f prime of 8. Okay, that's what you want to find out. Okay, that's what you want to find out. And negative 2.13 maybe, I'm not too sure. Okay, and since f prime of 8 is negative, okay, that's what we say, it's negative, the traffic flow is decreasing at t equals 8. Okay, so hopefully you were able to see that. Is the traffic flow increasing or decreasing at t equals 8? Well, increasing or decreasing has to do with the rate of change. And so I know I have to take the derivative of this guy. Okay, so I have to take the derivative of this rate of change. Okay, letter C. What is the average traffic flow over the time interval from 10 to 20? Indicate the units of measure. Notice this word right here, average. Okay, we're going to use the average value theorem. Okay, the mean value theorem for the integrals. And it's going to be 1 over b minus a, the integral from a to b of f of x dx, whatever your function is. Okay, so what does that mean? Well, we're going to go, this is your a, that's your b, so we're going to go 1 over 20 minus 10, the integral from 10 to 20. And what's our function? Well, your f of t dt. Because what is the average flow? Okay, well, how do we find average of something? Well, it's total divided by the time interval that it's giving you. So to get the number amount, you're going to take the antiderivative of the rate f of t. Well, now you're going to end up with 1 over 10, the integral from 10 to 20 of f of t dt. And whatever you get there, that's going to give you the value. Okay, and cars per minute. And I have no clue. I think, let's say it's 65.17. Okay. So that's the amount of average cars that are flowing through that intersection. Okay. But the important thing is understanding how to set it up, looking for those keywords. So when you see average, okay, boom, average value. Okay, mean value theorem. Okay. And then the last one, what is the average rate of change of the traffic flow? Now this is a little bit tricky. So look at what they're asking you. Average rate of change, okay, rate of change, that means derivative, okay, rate of change, average rate of change of the what? Traffic flow. Well, wait a minute, what's the traffic flow? The traffic flow is given by f of t dt. Okay, that's a traffic flow. Okay, well then, how do I find the derivative of this guy? How do I find the average over the time interval of from 10 to 20? Okay, now remember, average rate of change. And the other one is the average traffic flow that's coming in through that intersection. So we use the mean value theorem for integrals. Okay, well, how do you find the derivative? Well, go back to algebra 1. You're going to do f of b minus f of a all over b minus a. And what is that going to give you? That's going to give you f of, what is that, 20 minus f of 10 all over 20 minus 10. So you would have to take your calculator, plug in the 20 into your function, plug in your 10 into your function, And what's your function? Just in case you forgot, f of t is 58 plus 4 cosine of t over 2. And plug in 20 in here, find the math. Plug in the 10 in here, do the math, calculator. And let's say it is 1.214. Okay, but remember, you took the rate of a rate. So this is not going to be cars per minute. This is going to be cars per minute, or cars per minute squared. So hopefully, guys, you kind of got the hang of how we're doing these. You are definitely going to get one of these on the AP exam, almost guaranteed. But you notice that the more we do these, it's not really that difficult. Hopefully that helps. Let me know, and I'll make sure, if you need more examples, I will. And then this time I'll make sure I get the correct values ahead of time. All right, guys, thank you so much.